All right, so quiz 4. I'm gonna go ahead and just read it. The instructions aren't really there's not really a lot of instructions here, but it says add a calculate area and a calculate perimeter to square.java and call its methods in square test. The formula for area of a square is length times length, and the formula for perimeter is 4 times length. So what I needed you're supposed to turn in 2 files, the square.java and the square test.java. Square test.java should call area and perimeter. Both of these were in Dropbox. I apologize for those that were absent. I didn't specify that I actually did these or partially did them. So if you grab the one from Dropbox, I just put like a to-do of what you were supposed to do right there, right? I did pretty much everything else for you. So really all you needed to do was create those methods. The wrong thing to do would have been to come over here and add area and add perimeter as instance data that you're going to track for the square. Now, the reason why you do not want to do that is because area and perimeter are both dependent on the value of length. That means whenever you call it set length, you would have to go and modify your area and your perimeter, okay, which is a bad programming practice to do. Whenever you need area and perimeter, you just calculate it off length. All right, so you're going to make a method that's pretty much going to do the calculation for you and then spit out the value, okay? So I kind of gave you a hint on what you should name your method. It's always a good idea, not to fall into the trap of naming your method get area or get perimeter, because it kind of insinuates that there should be instance data for area and perimeter, okay? So another wrong thing to do would have been to say public float get area. I mean, I didn't take off points for that, but like I said, it kind of makes you think okay, well, I'm gonna need area for instance data up top. So I like to stick with the name calculate area, okay? Or some students, which you can also do, is just name it area, right? Nothing wrong with that, okay? But since I specifically said calculate area, I'm gonna go ahead and just use calculate area. And then really all you're gonna return is area. So how do I calculate area? Does anybody know? What is the area of a square? Yeah, length times length, right? So you could do length times length. Okay, and you just spit out your area right there. Okay, pretty simple. And then the next thing to do would be to calculate perimeter. So I'm gonna say public float calculate perimeter. And then what's the equation for your perimeter? Wait, what? Okay, number of sides times length, that's a good one. Or if you wanted to just be, take the long way of doing this, you could have really the perimeter is the sum of all the sides, right? That's the sum of all the sides of a square, length plus length plus length plus length. You could have done that way, but the shorter way of doing that would have just been to take the number of sides, or 4 times length. I have the number of sides declared as a constant up here, so I can use the number of sides and then times length. If you put a 4 here, I didn't take off any points. I know on your homework I expect you to use constants, but on a quiz I just want people to get the program working, pretty much. All right, so we're done with the class. That's how how simple it was. But just make the methods to spit out what you need. Now the next thing that you were supposed to do is hop over here and just call the methods. I already kind of did one for you, right? This one wasn't compiling before, but now that I added calculate area, this does compile. We do want to output this value though. So I'm gonna say system.out.println, and I'm going to spit out the area. So I'm gonna say area is, and then just S1, calculate area. And I'm just gonna copy this, paste it. Perimeter is, and then calculate perimeter. Save it, and now we can compile. I'll go ahead and compile in here and run. And you can see there's my perimeter and there's my area. Why is it so low? Oh, because I set my length to 0.001, right? So let me put it to something more logical. Let's do 5, right? So the area of when the side is 5 should be 25 and the perimeter would be 20. So area is 1, wait, what the heck? What am I doing wrong? Oh, wait a minute. Yeah, I did this. I didn't do it low enough. Let me do this. S1. Yeah, that should have taken. So did I get my set length wrong? If length is greater or equal to 0, you set your length. All right, so let's debug this problem. We're having this problem right now, but I don't know what's going on. So before I spit out my area, what I'm going to do is I'm going to just print out the object to see what the state of it is. The state will give me what the current length is. Okay, so I'm going to go ahead and compile and run. Oh, and that's right. Oh, you know what? I just ran the program before. I didn't recompile. That's probably why I got the same result the second time. Right, so
I modified that script that you used, but didn't save it, so it actually saves it.
oh, dang, that's a good idea. Yeah, can you send me that, message it to me?
Sure.
Yeah. All right, any questions on this? I mean, it was pretty, this quiz was like pretty straightforward. I know it was difficult because it's you're still kind of getting used to doing this, but I mean, I pretty much set everything up for you. All you had to do was just create methods to calculate and return the value, and then in your driver class, come over here and just return the value out. Any questions on that?
On the first one, square.
The first one. Oh, square?
On the square,
It-
your bottom. So, sorry, I'm trying to see the parts that got changed. Yeah, okay.
Yeah, so basically where I put the comments for to do is where the area where it changed. So this is in Dropbox now, right? I saved it, so it's in Dropbox. If you need to use this for a reference. All right, so with that, I'm going to go ahead and hop into the lecture. This is the last section we're going to talk about, and there's kind of, I mean, the concepts I'm going to cover today are a little more difficult, but it's not too difficult. But like once we're done today, we're ready for technically we'll be ready for a midterm. I understand that these are concepts that are a little difficult to grasp. So we're going to spend all of next week just doing examples and quizzes and things like that. And then the following week, which is October 14th, that's when your midterm is going to be. Okay, so we're going to finish today. We're going to have all next week to just do a bunch of examples and quizzes. And then on the 14th is when you're going to get your midterm. All right? So make sure you start preparing yourself for that. And I'll give a midterm review. I'll pull one out pretty soon, but I'll go over it on the 9th. All right, so let me open up the lecture. All right, so the last section we're going to talk about is the anatomy of a method. So method declarations, okay, no method declarations. Let's now examine methods in more detail. A method declaration specifies the code that will be executed when a method is invoked, which means called. When a method is invoked, the flow of control jumps to the method and executes its code. When complete, the flow returns to the place where the method is called and continues. The invocation may or may not return a value depending on the type of method is defined. Okay, so basically what you're talking about is here's my square driver, and then here's my square class, right? Remember this class, the square class is a blueprint for the square object, and this is the class with my main method, so we call it the driver class. So right here, I instantiate my object. Then I call the method setLength. What Java's going to do is say, okay, they want me to set the length. I need to hop over to where that method is defined and take those steps. Set method comes in over here. If you look, we passed in a 5 as a float. It comes in over here, and it's going to check to see if length is greater or equal to 0. If it is, then it's going to go ahead and set length equal to the value that is passed in, right? And then it's going to return back to the calling location right here. Now this is a method that is void. Does anybody know what that means? What does void mean?
Won't return anything.
Yeah, it just like, so in the method header, we specify the return type. When we put void, that just means that nothing's going to come back at that location. Okay, so that means that we cannot concatenate this to a system out print line, right? Because there's nothing there. It won't even compile. If I do a system.out.println line and just say like what happens, okay, and then I try to concatenate the result of the setLength method, because the return type is void, when I compile, Java's upset at me, okay? It's telling me that error, void type not allowed here, right? Because you're trying to paste something that doesn't return an actual data type. Are you trying to concatenate something that doesn't return a data type to a string? And Java's like, hey, what the heck, right? What are you thinking? All right, so that's what the void means, is that it just performs some statements and it's not meant to actually return any data back to the caller. Okay, but however, we do have the get length, right, which I did concatenate or pass into the printline method. And if you look at the definition for the get length actually returns a float. And it's just basically saying I'm going to return a float, I'm going to pass back a length, so then we can use that length here and we can print it out. Same thing for the area and for the perimeter that I just defined. So if I scroll down here, there's my calculate area and there's my calculate perimeter. These are actual float values, so I can do some type of math. So let's just say if I wanted to do something crazy, like, you know what, I want to know what the sum of the area and the perimeter are. So I'm going to go ahead and just grab this here. I'm going to say, okay, float sum is equal to s1.calculate area plus s1.calculate perimeter. Okay, and then I'll just say system.out.println. And I'm say sum of area and perimeter is, and then sum. I'm gonna go ahead and save that. And man, I kind of like having the compile and the run on Notepad++. Okay, so you can see there's my sum, right? It's returning back a float. We can treat those methods as any float data type. We can add it to something else. We can add it and then save the value to another variable. So you have to think of these methods here like this. What's highlighted, that is a float data type right there. What's highlighted here is a float data type right there, right? And the only reason why I know that is because when I defined those methods, I said, you know what? I'm going to calculate area and I'm going to give back a float data type. So Java knows that's a float and this is a float. Any questions on that? So that's how the return types of the method work. All right, let me hop back to the lecture and move on to the next screen. So here they're kind of giving you some arrows of the flow of control. So if a method call is in the same class, only the method name is needed. So here they're going through lines of code, call this method, hop over to the method, run the lines of code in the method, and once it's done, it hops back. Okay, and here's an example of, so this is an example of both the method and like these two methods being in the same class as this line or this method over here, right? Like you're running codes in this method here, then you hop over here, run them here, hop back. Here's an example of it being in a different location. So here's your main method. It reads through, comes to this line, hops over to whatever class defines it, running those lines of code. Now inside of this method, it calls another method, so then it hops over there, execute those lines of code, and then hops back. And then it finishes executing and then hops back over here, and then you finish the lines of code in the main method. Any questions on that? So it's like before chapter 4, we were pretty much just running like linear code, right? All in one class, all straight down. But actually, I take that back. In chapter 3, where we were calling methods, they just weren't our methods, right? They're methods of the Java standard library. So they were actually hopping to the definition of those methods, executing some lines of code, and then hopping back. Right, the method header. A method declaration begins with the method header. So the first thing, well, actually, they forget the visibility modifier. Right, the visibility modifier is public and private. They talk more about it in the following slides. Then you have your return type. Then you have your method name. So the method name is what we call an identifier. So it follows the rules of identifier. That just means that it can be numbers, letters, underscore, $, right? It just can't begin with a number. And then you have your parameter list. These are the list of parameters that you're going to take into your method. So far, we've only written methods that are taken into one parameter, but you can actually take in multiple parameters. And it's basically just telling Java that whoever invokes this method can pass in, is going to need to pass in an integer, and a string. Or they have to pass in 3 things in order for this method to be invoked. All right, then you have the method body. So the method header is followed by the method body. So here's your method header, and then here's the method body. These are lines of code that will be executed. So in this particular method, they find the sum of num1 and num2, and then they get the char in the string that's passed in at the location of the sum, and then return out the result. So it returns a char at these locations, or this location. The return statement. The return type of a method indicates the type of value the method is sending back to the calling location. A method that does not return a value has a void return type. A method statement specifies the value that will be returned. So like in your return, you just, like whatever your calculation you're going to do, like that value after return is going to be what is going to be sent back. Its expression must conform to the return type. So that just means like you can't, if you're saying something's going to return an int, right, you can't have a double or a float right there because it's not an int. All right, any questions on that? Okay, so this is how it actually works, right, from the calling location. So when a method is called, the actual parameters in the invocation are copied into the formal parameter list in the header. So here they're saying object calc, and they're passing in 25, and then some variable count. They're passing in a string. So those values are being copied over to the method, and then this method is doing work on whatever values are passed into it. Right. So whenever we declare our method, we're actually just kind of putting, like, making placeholders for data that we expect to come in. So like I said, these are also identifiers. They can be anything, right? Numbers, letters, $, underscore. They just can't start with a number. So anything of a valid Java identifier. But it's always a good programming practice to just name it something that makes sense, right? So I kind of messed up because I know it was kind of confusing for some students. When I named my variable for length, for the value I'm taking in, I put an L, and some students thought that was a 1. So that led to some confusion. That's kind of my fault. I should have just did something like len, right? I could have wrote length, but then I would have to find a way to let Java know which length I'm talking about, because there's 2 lengths here. There's this one, and if I decide to take in length here, then there's like some confusion there. I'll talk about that in a little bit on how you can avoid that confusion. Like if you did just want to use length as the parameter you pass in, and you have length defined as the instance data that you have in your class. Okay, local data, we've talked about this before. I don't know why they keep bringing it up, but I'm just going to read this slide. As we've seen, local variables can be declared inside of a method. The formal parameters of a method create automatic local variables when the method is invoked. When the method finishes, all local variables are destroyed, including the formal parameters. Keep in mind that instance variables declared at the class level exist as long as the object exists, right? So basically what you're saying is these variables here are local variables. They only exist in the invocation of that method, and then they go away, right? However, just locally, they don't exist, right? So if they still exist outside of the call, they're going to exist once the call is done, if that makes sense, right? All right, and then they give you an example. I'm not going to go through that example, but I'm just going to read this slide. Let's look at another example that demonstrates the implementation details of classes and methods. We represent the bank account as a class name account. Its state can include the account number, the current balance, and the name of the owner. An account's behavior or services includes deposit, withdrawals, and interest. Driver programs. A driver program drives the use of another more interesting parts of a program. Drives use of another more interesting parts of a program. Driver programs are often used to test other parts of software. The transactions class contains the main method that drives the use of the account class, exercising its services. So here is the example they gave you inside of the lecture. You can go ahead and look through this. I'm not going to go into this. Yeah, I can give you another example if you wanted to know more about this. So, yeah. They're basically just writing a driver and writing a class, and they're just kind of showing methods being invocated and sending back data. But you can look at that on your free time. Let's see. So, okay, constructors. All right. Note that a constructor has no return type specified in the method header, not even void. A common error is to put a return type on a constructor that makes it a regular method that happens to have the same name as the class. The programmer the programmer does not have to define a constructor for a class. Okay, that is a question that's going to be in your midterm and on your final. Okay, so a programmer does not have to define a constructor for a class. Each class has a default constructor that accepts no parameters. All right, so let me do an example of everything we just talked about. Okay, so I'm going to go ahead and close out the square test, and this one. All right, so I'm going to come over here. I'm going to make a new class, and let me save it into Dropbox. All right, let me see. What do I want to do? Okay, let's do a class for a cat. And I'm going to save this as, all right, cat. Hold on, let me think about this. Do I really want to do a cat? All right, let's do the dog. Okay, let's do dog, and let's save this dog. And I'm going to go ahead and make a class. Oops, I didn't mean to do that. I'm going to hop over here and make another one. We'll call this one the dog test. Right, so the dog test is going to be my driver class. It's essentially going to be the class that is going to test my dog class that I'm creating. Okay, so I'm going to say public class dog test. And all driver classes have the main method, so public static void main string array arguments. All right, and then from here, I'm going to instantiate dog objects, tester methods, do all that. All right, so I'm going to hop back over here. I'm going to make a class that's going to hold a dog. So I'm gonna say public class dog. All right, now I'm gonna think about some variables that are on a dog. Okay, so some variables that we'll have on a dog is a name, right? So a dog should have a name. A dog probably would also have a breed, and a dog would have an age, right? Those are three important things, right? Name, breed, age. And I'm going to go ahead and I'm just going to make the to string for this right now. Okay, so I'm going to say public string to string, right? And then all I'm going to do is I'm going to just print out the current state of my object. So I'm going to say return string dot format. And I want to say dog, and I want to give the name, put a placeholder there, the breed, put a placeholder here as well, and the age. And I'll put a placeholder there, right? So %s is a placeholder for a string, and %d is a placeholder for an integer. And then I'm going to pass in the name, the breed, and the age. Okay, pretty straightforward. I'm just trying to I'm taking my time writing this class, and then I'm gonna go test it just to see the current state of this object. Okay, so I made this dog class. Now I wanna test my dog class of what I've written so far. So I'm gonna say dog, and I'm gonna say dog1 is equal to new dog, open close parentheses, and then I'll say something like system that out dot println, and then I'll say dog1. I'm going to go ahead and use command prompt to test this. So I'm going to change directory to Dropbox, public, NVC, Java shared content, demos, chapter 4. All right. So I'm going to go ahead and compile my dog test. Okay, so since dog test uses dog, it also compiled dog. And I'm going to go ahead and run dog test. Okay, so you can see the current state of my dog object is the name is null, meaning it never was set. The breed is null, meaning it never got set. And the age is 0, which is just a value that was given to the age because it never got set. Okay, so I didn't actually define a constructor, right? I didn't define a constructor. So because I didn't define a constructor, Java went ahead and gave me the default constructor that doesn't take in any values. So if I hop over here, you can see there's no constructor created. The only thing I have is variables for my instant data, and then I have my toString method. Now, if I wanted to make a constructor so that I won't have null for the name and null for the breed and 0 for the age, I can come over here and define a constructor. I can say, okay, well, public dog. I'm not going to take any data into my dog constructor, but I want to go ahead and set name to some default value, so it's just not null. And I want to set breed to some default value, so it's just not null. And then maybe age as well. I think age is probably okay at being 0 personally, but maybe for name, like just say, I don't know, you want to do something like not set. Like maybe this is for like some database at a veterinarian or something, and you don't just want to show null or a blank name or a blank breed. You just want to say something like not set, so that when you actually print out the value, you see not set, brings attention to it. I don't know, you're the programmer, you decide what you want to put in this thing. But now when I hop over to my dog test and I compile and run, you can see that I'm getting not set as my name and not set as my breed. Okay, so the first time I compiled and ran this, right, I did not have a constructor. So Java used the default constructor, which it didn't really do anything. It just created the object, put it in memory, didn't set or initialize any of my variables. But in this case, I wanted to specify the name of the dog is not set, the breed of the dog is not set, and the age of the dog is 0. Okay, so that's the benefit of doing the constructor, is to set up the data so it's not in some weird state. Okay, because just say I got rid of this. Okay, I got rid of my constructor, and now I'm back to having the name being null, right, and the breed being null. Okay, and then I'm saying, you know what, I'm gonna go ahead and make my getters and setters for all this data. So I'm gonna say public set name, and then you're gonna take in n for name. I forgot to put the void here. Okay, so then we're gonna say the name is gonna equal n. I'm gonna go ahead and copy this 3 times or 2 times, right? And then I'm gonna do the same thing for my breed. Right, and for my age. All right, and then I'm going to make getters for all 3 of those as well. So say public string get name. I'm going to return name. And I'm going to do get breed. Return breed, and then also age, which is an integer, so I got to return the return type, or change the return type to an int, and then pass out age. All right, so I still don't have a constructor, so my data is initially null and the age is 0. So all I did was add getters and setters to set the name and to get the name. So hop back over here to dog test, and I'm going to go ahead and compile and run just to verify that, okay, well, my dog still isn't set correctly. So let's just say, okay, well, my dog, his name is Fido, right? So, oops, that's not Fido. What the heck? Fido. That's still not Fido. All right, save that. Hop over here, clear, compile. Dang it, no semicolon. Nobody caught me on that one. What the heck? All right, so semicolon, compile, run. You can see that Fido got set. Okay, so then I can do cool things that I can do with strings, like I can say like your dog's name starts with, and then do something like dog1 dot get name dot char at 0, right? You can do all the cool things that you can do with the string. So when I hop over here and compile and run, you can see that it says your dog's name starts with an F. Oh, that's so cool. I want to do the exact same thing on my breed. Okay, so your dog's name, your dog's breed starts with a, and then I'll just get my breed right here, and then hop over here, compile, run. Okay, but this time I get a null pointer exception. Okay, can anybody tell me what happened? Like, what's that? Yeah, I didn't set a breed, right? So because I didn't set a breed, breed was still null. So null means that there's no object there, right? So whenever we create object reference variables, it's just basically a variable that points to where the object is in memory. But null means it's not pointing anywhere. It hasn't been set, meaning there's no object created for breed. So because there's no object, that means it's not a string. Even though we said the data type is going to be a string, it's not actually a string because we haven't actually created that string. So that means that methods like char at 0 cannot exist on something that's not a string. Does everybody agree with that? Right, so it might like behoove you to like, I don't know. I mean, maybe you want to return null and just have everybody just understand that, okay, when the dog's not set, you're just gonna have to know that you're gonna get back a null. Or maybe you do want to have that constructor to where you have at least some default value in there, perhaps. So come back over here, right? Put in our constructor. We'll just say name initially. Oops, I didn't mean to do that. But name initially is, not given, We do it in all caps, like we're upset about it. Not given. And the breed was not given, and then the age, oh dang. Zero, right? So now we hop back over here. We're still not setting the breed, but at least we'll get, this won't crash. Now, you can also run into the problem where if you were to set the string to like an empty string, it would still crash because your object, there's no index 0 in that string. But it's all up to you. You're the programmer. You decide what you're going to do. But you can see that your dog's breed starts with the N, which is still, to me, still wrong because the breed was never set, right? But there's all these things that you have to think about now that you're the one writing the constructor and returning the data and deciding what you're going to do when you initialize this object. Are you going to give it a default value, or are you going to leave it as null? Like, what exactly do you want to do inside of your constructor? Me personally, I feel like if I don't have a name, if I don't have a breed, and if I don't have an age, then you don't have a dog. So I'm not going to allow them to create a dog unless they explicitly give me the name, the breed, and the age. Okay? I want all those three things if you expect me to create a dog object for you. Like, that's just the way I think. Depending on where you work at, maybe they think differently. I do see a lot of empty constructors, right? And data can be null. But then again, you can still pass any null value into this constructor. Okay, so the way that I would do this constructor, let me just comment this out so that it's there when you look at it. Okay, so now I have name, but I also have name up here, right? Is in my parameter list. So when I do something like name is equal to name and breed is equal to breed and age is equal to age, right? All you're doing is just confusing Java. It doesn't know what you're going to do. It's actually thinking that you're just taking the name here and assigning it to itself, taking the breed here, assigning it to itself. It doesn't even think you're trying to use your instance data, because when you come over here to compile and, oh, well, it doesn't compile because I need to pass in data. So I'm going to say, okay, well, I want my dog to be Bob. I think Bob's a good dog name. Let's see, breed, we'll say poodle, and age 7. All right, save that. Let me clear my screen. Compile. And run. Okay, so I created Bob, and he was, forgot what the breed was. Oh, poodle, and his age was 7. Like, that data didn't actually make it into the object. And the reason it didn't make it is because my instance data has the same name as the names in my parameter list, right? So it's ambiguous to Java, like what you're trying to do, because the names are the same. So there is this cool reserved word you can use. It's awesome. It's amazing. It's called this. You do a dot. This means the current instance of the object. So whatever instance of the object that you're calling this on, you're going to do a dot and then get the actual name, the breed, and the age. So now Java is able to distinguish what name, what breed, what age you're talking about. So you can have variable names in your parameter list that match your instance data, right? And we could avoid problems like the problem we ran into with the square where I just put an L, it looked like a 1, confused some people. I could have just wrote out length inside of those, inside of that class, okay? But in this case, I'm going to use this, and I can use name, and I can use name here, right? This dot name is the name of the object that this method is being called on, and the name without this is just the name of the variable from the parameter list. All right, any questions on that? All right, so now when I go to compile, I compile and I run, and you can see that data actually stuck, right? So you have to be careful with that. If you do want to match your parameter list variable names with the instance data names, you have to be careful. Okay, so the other thing I wanted to show is identifier names. Now I'm just going to make this method, let me see. We'll say string, and I'll make something called speak. Right. Bark. Okay. So I made this variable, or excuse me, I made this method called speak. I made it public. So this method can now be invoked through my object. So I can say system out print line, and I can do something like dog1 dot get name, right? That's the name of your dog. And I can say says, and then I can say dog1 dot speak, right? And this returns a string. So it is going to be a string right there that's concatenated to says. So when I hop back over to my console, I compile, I run, you can see that Fido says bark, bark, right? Pretty cool, amazing. Hop over here though. Now, speak is an identifier, right? So an identifier is words, letters, numbers, $ underscore. The one rule is that it can't start with a number, right? So to me, that's like just amazing, right? Like you can have some crazy name like $ underscore, and Java should be okay with that, right? Because that's what the rules of identifiers say, right? And it will actually work. So now, if I want my dog to speak, I have to invoke that method. So I'm gonna hop over here, and instead of putting speak, I'm gonna put, take it, I meant to copy it, I guess I didn't, $ underscore, save it, come over here, compile. It compiled, amazing, right? So let me clear my screen and make sure that it actually runs, and it runs just the same. I didn't notice any difference, right? So I am using a valid identifier name, $ underscore, and it in fact worked. Okay, any questions on that? I just wanted to show, like, demo that, like, we've talked about these rules identifiers, but it seems like we always follow this pattern. Now, of course, this is a violation of our coding standard, so method names should also be meaningful to what the method actually does. Okay, so $ underscore doesn't have any meaning to me, or to you, I mean, unless you're speaking in code or something. So if this method is gonna, return a string of the dog talking, then you can just like name it speak or talk or something. I don't know. It's up to you, but it definitely should not be $ underscore. Okay. All right. I'm going to go ahead and hop back to the lecture. So that's constructors. And let's see. Quick check. How do we express which account object's balance is updated when a deposit is made? We didn't actually read through that demo, but what they're meaning is how do we express which account balance is updated is you basically invoke the method on the object that you created. Okay, I guess I should have shown that as well, meaning if I came over here and I created two dogs, right? I have Fido, or actually let me get rid of that. I have Bob and I have Tom. Okay, so Tom is a German Shepherd. I think that's what you spell it. I don't know. Could be wrong. No matter. This is programming class. Okay, so I have dog 1 and I have dog 2. If I wanted to know the name of the dog at dog 1, then I can say dog 1, right? And that's going to give me the name. If I wanted to get the name of the dog at dog 2, then I have to actually invoke the method on dog 2 object, right? Same thing here. Invoke the method there. Okay, now speak is doing the same thing for both of them. So let me just go ahead and modify it just a little bit so that it's kind of more personal of the actual dog, right? So I can say bark, bark. I am of the, and then we're going to say breed. Okay, so now the dog barking or speaking actually has more personal meaning to the actual dog that you're invoking this method on. So I'm going to go ahead and save this and come over here and compile and run. And you can see that when Bob barks, he says he's of the poodle breed. But when Tom barks, he says he's of the German Shepherd breed. Okay, so that's what they're meaning here when they're saying, how do we express which account object's balance is updated when a deposit is made? So if you look through their code, they have methods called deposit and balance. So it just invoke the method on the correct object. Okay. All right, and that's it for anatomy of a method. I'm a little surprised. There's a few more things that I wanted to go over before I give you a quiz to do. But I'll do it next week just because it's not really like pertinent to the homework in chapter 4. But technically right now we know everything we need to know about chapter 4 to take our midterm. The other thing I wanted to show you is how to create multiple constructors and overload methods, meaning you have the same method name, but it does something different. I'll go ahead and talk about that next week because I don't want to like give you a bunch of stuff and you think it's things that you actually need to know for the homework and for the midterm coming up, but it is something that we do need to go over. Because I don't think I asked you on the midterm to create multiple constructors or overload your methods. All right, so are there any questions on anything that we've talked about so far? Right now, you're good to go with chapter 4. You're able to do the homework. You're able to take your midterm. Okay, we're going to spend next week just getting more comfortable with this. We're going to have like 3 quizzes every day, and I'm going to do examples, and we'll hold each other and encourage each other. Okay, so there's no questions. Okay, so I'm going to go ahead and give you guys a quiz. So I don't have no idea what I'm going to do, but let me think of something. This time you're going to write something all the way through, not just add to pieces of what I'm doing. So let's see. So quiz 5. And I'm going to give you a little more time to do this, but I do encourage you to finish it tonight. I probably won't sit down until Sunday is when I'm probably going to sit down and grade this. So you're going to have a couple of days to do it. It's okay if it takes you a couple of days because, it is a little difficult to wrap your mind around some of this stuff. I'm going to put the due date as today just to scare the students who don't show up. But you should try to get it done tonight. Okay, so let's think about what we want to write. Okay, so I did a dog. Let's see. Something similar to a dog that has multiple instance data. What's that? Cat. Let's do, dang, I have no idea. A book, but that's too many stuff. Because, like, the dog is actually in your homework. So I don't want to, like, give you two. In the book, there's one called book that's already in your homework as well. Let me see what I asked my summer class really quick. So that's exactly what the homework tells you to do. Yeah. Yeah. Summer 2019. So the last time I taught this, let's see. So quiz, let's see what quiz 5 is. Quiz 6. Coin, we did that one already. Rectangle, oh, this is a good one. So length, yeah, this is actually a good one because you can kind of use a square for reference, but this time it's going to be a little different because you're actually going to have a width, right? So you're going to have a getter and setter for width, but you do the same thing though, area, perimeter. I don't know, it might just be like a bunch of copying. Ooh, octagon, man, that's crazy. Now we're going out there with this. All right. Dang it. You know what? Let's just do the rectangle. I can't really think of anything. So it's going to be similar to the square. So technically you can probably just modify what you did for the square. But this time you're going to add a width. You're going to do the perimeter and the area. Is there anything else you want to know about a rectangle besides length and width? No, let's do a cube. Yeah, there you go. Let's make it really difficult. No, but then like the cube has the same dimensions for every side, right? Yeah, no, that's okay. Do you read the homework and you just like?
No,
there's a box in the homework too.
I have not even touched them.
Okay, all right. Yeah, you named everything that was in the homework pretty much. Okay, so we'll just do the rectangle. That way you can kind of use the square kind of like as a, as a starting point, but you're just adding one more dimension. So you're going to do is create a class called rectangle that has floating point instance data for length and width, and then you're going to make getters and setters for length and width. You're going to need a constructor that takes in length and width, and then create a method to calculate and return the rectangle's perimeter. Create a method to calculate and returns the area, and then I say override the toString method. So whenever you create the toString method, there is an existing toString method on the object class. I've showed you guys that before. You probably forgot because it's like stuff coming at you left and right, right? But if you don't actually specify a toString method on a class, meaning if I come over here to my dog and I get rid of this, I delete it, save it, and then I hop over here, wherever you see the toString printed out, there's going to be a different string printed out. And the string that's going to be printed out is the class name and kind of like this hexadecimal value that's associated with where the object is in its memory. All right. So that's the string that's printed out. So whenever we make the toString method, we're actually overwriting it, meaning there's something there in an underlining class, and we're creating our own so that that one doesn't get called, and our own special toString method will get called instead. Anyways, I just wanted to clarify that. So let me hop back over here. So that's what I mean when I say override, that it confuses anybody. And then I say create a driver class that instantiates a rectangle object that tests all of its methods. Be similar to the square test. And then think about what could have you do to filter. Okay, this is one I want you to start thinking about filtering data in your setters. So what can you do to something that has dimensions that you could put in your setter to prevent your data from being something that doesn't make sense? Yes.
Is that like using an if statement to create a value and then see if that value fits within a certain parameter?
Right. So what parameter do you think? Like, what doesn't make sense for a rectangle?
Greater than 0.
Yeah. So negative, right? Because there's no negative dimensions. So I guess I don't know. I would say greater than 0, right?
Yeah.
Because a 0 dimension also seems kind of weird to me as well, right? So anything in our dimension has to have some type of length or width, right? Like even atoms have like a length and width, right? So, yeah, anything negative is like won't exist in our dimension unless there's an alternate dimension existing as we exist. I don't know. All that's confusing when I think about all like that and space and all that. I start to cry and stuff. So I don't want to think about that. But anyways, so do this, get it done by Sunday. It would behoove you to try to get it done tonight because it's all like kind of fresh in your head. Whenever you put something off for a few days and try to do it like before it's due, it's just a mess, right? So go ahead and start that as soon as you can. So that's all I have. You guys are free to go or stick around. Class comes in at 8:10. I will be here till 8:10. I'm okay with moving to a different classroom till about 8:30, and I can help you till about 8:30. Have a good weekend.